Yeah. The second program, which is stated in the syllabus, is write a program to find the sum of first 10 integer numbers. What does this states? This program states write a program to find the sum of first 10 integers. That is the numbers from 1 to 10. Those are the integer numbers, the first 10 integer numbers. So I want to code the ARM processor in such a way that you should get the output by adding all the first 10 numbers. What will you get by adding all the first 10 numbers? What will be the resultant? What will be the number you get? Can someone calculate and tell me what is the addition of 1 to 10?
55, sir.
Yeah, 55. The output what you should get is 55. That is regarding your decimal part. As you all know, whatever the output we get in the software, it will convert whatever the ARM processor we are using. That is LPC 2148. The output will be in the format of what will be the format of the output in your software or the processor you process? It will be in the form of
Hexadecimal, sir.
good. It will be in the form of hexadecimal. That is, whatever the word length which the processor takes, it will be of how many bits? Can someone tell? What is the word length of an ARM processor?
32 bits, sir.
Yeah, good. The word length of an ARM processor is always 32-bit. And whatever the output you get from the ARM processor is of 32-bit length. That is, the data is of 32-bit. So you do remember, this is also a Viva question. The word length of an ARM processor is 32-bit, and whatever the output we see once we code the program, it is also of 32-bit. The format will be 0 into 000 and so on. What will be the resultant? That is, after 6 zeros you will produce the resultant of that particular operation. So we'll start seeing how second program works. I'll just copy paste the program in the software. So can someone tell how to start up with the software part? If someone has not attended the previous laboratory, do concentrate. First, whenever the screen appears of the software, first you have to go to project, new project, that is new micro version project, give a name. Now, which program we are doing? We are doing second program. I will name it as program 2. And check out, this will be already assumed that it is a project file by giving the extension UV project. You need not worry in this case. Now I'll give save. Once you give this save, what you will get? You will get a pop-up menu. In that pop-up, you have to search for which processor you have to search.
LPC 2148, sir.
LPC 2148. Sorry, LPC 2148. Yeah, I got LPC 2148 processor here. I'll click on this and give it OK. Now it will ask for a startup. It is not required in the software part, so I'll give no. You can check out here. There is a target created here with respect to which there is some there is a source created with respect to that particular target. After this, I should go to File, open a new file so that I can start typing the program. So once the screen is visible, I should type the program. I'll paste the program. Now, first I'll check the indentation of the program. I should give tab here. Then I need not give tab here. It is okay. Yeah, the rest is all fine now. So coming on to the explanation of the program. So the first program, every program starts with this same terminologies here. What does this area specifies? This area basically specifies it is an assembler directive, which what happens if you give area there? This area basically instructs the assembler to assemble some new code or the data for that particular program. What is this SUM? This is actually naming of the program. You can give anything which is related to the particular program. So what does this code tells? Code basically tells the type of machine instruction that is you will be giving in the code This basically tells it can be code or data. If it is code, it is a machine level instruction which is given to that particular code. Then what is this read only? If there is code, it is automatically, you should remember, you should give only read only. If you are giving code, this tells what type of machine instructions you are using. That is read only instructions you are using. So this is about the first line of your code. Then starting of the program. How to start a program? It will start with the entry, then some name. This might be start, or I have named the program as sum10, that is sum of 10 numbers. Now, as we all know, we'll be now using huge number of registers, so that we'll code with respect to the LPC 2184 processor. What is the first condition here? First statement here, move R1, that is register 1, with respect to the value 10. That is, you are giving the value for R1 as 10. The value 10 is being stored in register R1. Then check out the second statement. It is giving R2 comma 0. In this line, I am just creating an empty register so that I will be using it in the addition. Okay, so this is an empty register which is being created, which consists of value 0. Now I'm starting a loop. This loop is used to add two registers, that is R1 as well as R2, and store these two registers value in R2. Okay, what is the initial value of R2? It is 0. What is the initial value of R1? It is 10. So as I have given addition function here, that is addition command, that is add command here, it will add R1 and R2 and store the resultant of this addition in R2 register. That is, what will be the value of R2 now? It is 10 now, because you have added R1 value 10 plus R2 value 0. Now the resultant of R2 will be 10, which is stored in R2. Okay, then once I have added the value of R1 as well as R2, I should decrease the value of R1. That is, this in this statement, this subs subs basically states you are decrementing the value of that particular register, so that you can link that particular register in your another statements in the further execution of the program. Now what is the value of R1? It is already stored in this, right? It is 10. Now that R1 value will be decreased by 1. Now the value of R1 will be 9. So again it will call that particular loop. I'm using one new function here called as, new terminology called as BNE. Do note down, students. BNE basically tells branch if not equal. I do repeat, BNE basically states branch if not equal. So what does this basically tells? You are linking to this particular loop if the previous statements are not equal. That is, if I consider R1 value. Now check out R1 value here. What is the R1 value? 10, right? In basically here it is 10. Is 10 equal to 1? No, right? So this loop is called, this loop is created. Once this command is found, and once the control comes to this particular line, it shifts to the loop here and it keeps on repeating. Now what happens here? Basically R1 value is 10. I will decrement that R1 value by 1, which is nothing but you get 9. Now I should add that particular value. Now R1 value is what? 9, right? I'll go to the loop again. I'll change the values. R1 value is now 9. What is the R2 value which we got previously? It is 10. I will add 10 plus 9. Similarly, I will reduce R1 value again, decrement, that is 9 is decremented to 8. Then what is the initial R2 value? That is 10 plus 9, right? It is 19. Then I will add R2 value 19 plus 8 and store it in R2. So simultaneously this keeps on repeating till R1 is 0. At one stage, if R1 value is 1 here, if I decrement 1, you will get 0, right? If that both are equal, this branch doesn't work. It will just come out of the program and then end the program. Okay, is the program clear to everyone? Yes, no, confused? Something. You should tell something so that I can proceed further.
Yes, sir.
Yeah. Is it clear? Okay, I'll just again repeat once again. First, two registers are used with where the first register value is 10 and the another register value is 0. Then I'll call a loop so that it will add two registers, that is R1 and R2, and store those values, that addition value in R2. Now I should reduce the value of 1. So I'll be using this statement called SUBS, this instruction, to decrement the register value. Now the register value is decremented. What this basically, this whole instruction tells you are decrementing the value of the register here. Now the register value is 10. If I decrement it by 1, I got the register value as 9 here. So I have called a new instruction called DNE loop. What DNE loop tells us, branch if not equal. That is, if these two values are not equal, if not equal, you call this particular loop again. Now, what is the value of R1? 9, right? So 9 as well as that particular register value is not equal. So it will again call that particular loop, and then it will add that particular instruction, that is the value to that particular register. That is, in the initial step, R1, what is the R1 value? 10 and 0. Now you got 10. R1 value, R2 value was 10 there. Now R1 value I reduced. What is the R1 value? 9. Initially, what was the R2 value which we got in the initial step? It was 10. 10 plus 9. Now I got R2 value as 19. Then again I will decrement R1 value. That is 9 is reduced to 8. Then I will add upon it. That is 10 plus 9 plus 8 is then stored in R2. This keeps on repeating till R2 value is not equal to R1. Okay. When this loop stops, whenever the R1 value doesn't is not equal to that particular value. That is, you keep on repeating R1 till it goes to 0. Till the R1 value is not 0, you keep on repeating this particular loop. Then once the R1 value is 0, you will come out of the loop and then end the particular program. Okay, hope now everything is clear with the second program. So can we move on to saving the file and execution of the file? I require some response from your side because I won't be able to see you all, but at least you should tell me that you have understood. Yes, sir, you can go further and on.
So you can go further, sir.
Yeah, okay. Please do replying me so that I'll know that students are listening to my concepts. Okay. Yeah. And now what is the next step? I should save the file. Go to file, give as save. What happens here? Check out the folder if it is same. Yeah, the folder is same. The location of the file where it is to be saved is same. Now I'll give the file name as something PGMM, program number 2. What is the next step? Don't forget to give the extension here, that is .asm. I should save the file. You should check out here. It should be in all files so that you are saving .asm here. Now I'll save the file. Now check the changes here. The color of the instructions have been changed. That tells you the program is perfectly saved in the software. Then after that, what I have to do, I have to add this file into your source group. That is which comes under target. Now I will just right click onto this source, add existing file to source group 1. Check out, I am not finding any of the files. So what I should do there, .c it is assigned here. So I should assign it as .src. Then I'll search for the file name. What was the file name? That this is the file I had saved. So I'll click this file, I'll click this file, give add, and then close it. Now you can check by clicking on this plus mark. You can check the file is been added to that particular source. Now what is the next step? I'll again give save and then build the program. You can check out here. There are no errors. The program while building, it will shows how many errors, but there are no errors here. So once you have no errors, what is the next step? I should go to debug, start and stop debug session. It will give you the size of the code, and then you give OK. Now you can check out there are registers formed here. So I'll just maximize the screen of the registers. Then again go to debug, give run. Now your program is running, and then again go to debug, give stop. Check out here where the resultant should be stored, students. The resultant is actually stored in R2, right? What should be your value? What will be your hexadecimal value of 55 is the hexadecimal value is 37. That is, the 55 will be your output. The addition of first 10 integer numbers, the output is 55. As you all know, the output will be stored in hexadecimal. The hexadecimal value of 55 is 37. It is stored in register R2 here with respect to different conditions. These are some of the registers which are being linked with respect to that particular registers. So I guess hope everything is clear with this program. It is just adding the first 10 numbers, that is the integer numbers, and storing it in registers by converting the output in hexadecimal. So this is the output of this particular program. Okay. So can we move on to the next program? That is the third program. In the starting, the three programs is actually easy. So I'll be explaining two programs in one session. If the program is a bit longer, I'll just explain one program in one laboratory. So as the program is very small, I will just take another program also, that is program 3. So we'll check out what is program 3. Okay. Hope this is clear. Can we shift to the program 3?
Yes, sir.
Yeah. So what I have to do, you please don't quit by this stage. You should not quit because the software might malfunction at that time. You should again go to debug, give start or stop debug session. Now the debug session has been stopped. Now the normal screen appears of your program. Now I should go to another screen so that I will create another program. What is to go to another program? I will go to project, new microvision project. Then I'll create one file name, that is pgm is already there. No, program number 3. Okay, give save. Yeah, now I should give the processor name LPC2148. I'll select the processor, give OK, give no to the pop-up, and then I'll see there is a source created. Then a new file I should create so that I'll type the program here. So I have already typed the program here. Do check the, I guess, students, you have not noted the program, right? Sorry for that. You should tell me, right? We studied program 2. Open. Yeah, students, do copy the program. Check out the question. The question is, write a program to find the sum of first 10 integer numbers. Do copy in your observation. Write a program to find the sum of first 10 integer numbers. So this is the question. The next. Which was the folder I created? Yeah, I can't directly open that. Okay, fine. I'll go to the new project. Again, I'll create a new project. Okay, PG3. I'll just give it as program 3. Okay, it is already there. Okay. I'll just copy paste the third program. Okay. So what does this third program states is you have to write a program to find a factorial of a number. So what is a factorial? If I give the number as 3, what is the resultant? You should get the resultant as 6. The factorial of 3 is 6, right? So that is the program. You are just passing a number to the program so that you will get the factorial of that particular number. So we'll check out how the program works. First, there is a tab space here. Then I'll start the program where the first line indicates the assembler directive, which basically tells or instructs the assembler to assemble a new code or the data. That is nothing but the area. Now, factorial is just the name of the program you are specifying. Code, this is the machine level instruction you are giving. This basically tells what kind of machine instructions you are giving. The type of machine instruction you are giving to the program is read only. Then there is an enter there. Then I will start the instruction of the program, that is start typing the program, that is start of this entry basically tells entry of the program, that is starting of the program. Again, I'll give one enter so that there is some space between the lines which doesn't confuse you. Then what is the first instruction here? There is move R0, 7. What does this instruction tells? You are just creating a register or not which consists of value 7. The value 7 is being stored in R0. What does the basically tells is you are just finding the factorial of a number 7 here. Now, the whole program should give you the output for factorial of a number, that is 7. Now, this value, I will store it in another register, a temporary register called as R1 register. That is, now the R0 value is already 7. I'll move the same value into R1 as well. Now, both R1 as well as R0 value as R0 as well as R1 has the value 7. Then I will create a loop here which tells create a loop for fact where you have to just reduce the R1 value by 1 and store that value in R1. That is, you are reducing the R1 value. That is, what is the R1 value? 7 here. With the help of loop fact, I am just reducing R1 value and storing that particular value in R1. Now, what will be the value of R1 here? After reduction, it is 6 here. So, I'll compare with the R1 value with respect to 1. That is, checkout. The CMP is nothing but comparison instruction which is used in the processor. I'm telling this particular control to compare R1 value. What is the R1 value here? It is 6 here. So, I should compare with 1. So what happens here? 6 is equal to 1? No, right? So at that stage, what I have to do? I am using another instruction here called BEQ. This is actually the previously we used which instruction? It is BNE, which is branch if not equal. In this program, we'll be using BEQ. What does it tell? Branch if equal. That is nothing but if the register R1 value is equal to 1 with respect to this condition, if this both are equal, then you have to stop that particular execution there. You should stop. But you can see R1 value is 6 here and this value is 1. Is it equal? No, right? So this command, this line will not be used. That is, it is not executed. It will just go to the next command, next instruction. I have used multiplication instruction here where what is the R0 value? 7 as well as R1 value. What is the R1 value we got here? It is 6. You are multiplying 7 as well as 6 so that you will store that particular resultant in R3. Now R3 value is what? 7 into 6 here. Now I will move that particular R3 value to R0. Now R0 value is 7 into 6 there. So R0 consists of that particular value. Then what happens? This is basically the resultant. The resultant you should get in R0 as well as R3. R3 as well as R0 is the resultant of your program. The resultant is stored in R3 register as well as R0 register. Now, again, I am using BNE fact. What does BNE tells? BNE tells branch to the loop if not equal. That is, BNE is not equal function. You are just, if this is not equal, that is, if this is equal, you should stop. If this is not equal, you should again go to the factorial loop, which is defined here. Okay. Now check out what is the value of R0 as well as R3. It is 7 into 6. Now again it will go here. Again it will change the values of R1. And then again it will compare with it. Now you will get the value as 5 here. Then again it will check it is not equal. Again it will execute these two and keeps on implementing. First you will get the value as 6, that is 7 into 6. Then again 7 into 6 into 5. Again 7 into 6 into 5 into 4. Then 7 into 6 into 5 into 4 into 3. Then 2. Then 1. So simultaneously it keeps on looping this particular statement and then give you the resultant in R0 as well as R3. Okay. If you can check out here, if that particular branching loop is equal, if R1 is equal to 1 here, it will directly compare it. You can check both are equal. Now it will stop the particular execution. It won't go for further because what is the final this in factorial there? 7 into 6 into 5 into 4 into 3 into 2 into 1. What is the last number you got? 1. So now the register consists of value 1 and then it will compare. It finds it as equal and then it will stop that particular program for execution and come out of the loop and then it will end the program. So let's see how the output looks like with respect to this particular program. I'll save it as program number 3 dot, what is the extension? Dot ASM. Check out the location. It is correct. I'll give save. Check out the color of the codes, instructions. It is changed now. I guess there might be some errors. Yeah, but we'll again save and then I'll build. Oh, okay. I have missed creating the target here. I have not included the files to the source. So at that time, if you have not included the source properly, if you have not linked the program to the source, you can get build target 1. This will be blinking here. So at that time, right click, add existing, that is pmm.asm. Check out where is that. Yeah, this is here .asm, add and close. Now you can check the program is linked to the source. Again, I will give save. I'll build the program. Yeah, there are no errors now because I was doubting if it had some errors because it is not building directly there. What was the error there? You have not linked the program to the source there. Okay, so you can check out what kind of errors you might get while execution. Then what to do next? I'll go debug, start or stop debug session. I'll give OK. You will get the register list here. Then I will just expand the register list. Then I'll give run. Now the program is running. I should stop running of the program. You can check out here where you have to include where the resultant of the program should be stored. It should be stored in R3 as well as R0. You can check out both the values are same. This is the hexadecimal value for 7 factorial. What is 7 factorial value? It is 5040. So this is the program which shows you the factorial of a particular number. So I'll use a small number so that you can understand. I'll stop the debug session. I will use, just to be simple, I'll use 3. I should calculate factorial of a number, which is nothing but factorial of 3. Now I will again save, give build, no errors, then debug, start or stop debug session. Okay. Now I'll get the registers. Then again I'll give run. Now the program is running. I'll stop running of a program. Now check out, what is the factorial of a 3? Factorial of 3 is 6, right? 3 into 2 into 1. It is 6. Now check out the result. It is, as it is stored in R0 as well as R3, the resultant is 6. Hexadecimal of 6 is represented in R0 as well as R3. So this was the program for finding the factorial of a number.